lubrication, first thing you want to do with the system is to isolate the system, right? So you isolate the system, you lock off certain flow, right? The second step, you perform a lockout tagout procedure. So beside you, the maintenance personnel, the fabricator, the fitter, locking off the system, we also have to have a lockout tagout procedure in which we could put a manual lock and a tag on the system notifying people that someone is working on this system and it should not be turned on, right? Our lock is to ensure that no one turn it on by accident. So after we do these two steps, step number 3, removing the valve from the system. Number 4, you secure the valve. Remember, you're going to work on the valve, so you secure it most likely in a vise, right? Number 5, you open the valve so that the disc is off the seat. Step number 6, you remove the bolts from the bonnet. Number 7, you remove the bonnet from the valve body. Step number 8, remove the gasket and clean the surface area. Now that area where the gasket rests in or the seal rests in, you know, after years in service or after service at various temperature, they have a tendency it might get probably corroded, it might get a little pitted. So you'll have to remove it and make sure that it's clean and smooth. Right? Step number 9, you make or you replace with a new gasket, right? Remember we did laying out the gasket, right? So it's either you make a gasket or you replace the gasket. Step number 10, and this may apply for some valves, right? Some valve, the gasket may need lubrication. Sometimes it may not. But if the gasket need lubrication, you lubricate the gasket. It's more or less a grease you place on the gasket face, right? Step number 11, place the gasket on the valve, securing it properly. So you have to make sure that your gasket or your O-ring, your seal, is seated properly. Once seated properly, you go on to the next step, which is placing the bonnet onto the body of the valve. Right? Step number 13, you clean, you lubricate the bolt thread. That is the bolt that is going to connect the bonnet to the body of the valve. So you clean it, you lubricate it, you chase it. That means you pass a die over the bolt if necessary. Right? And step number 14, you replace your bonnet bolt and tighten. So once you clean it, stop, you replace the bolts and you tighten. And that is the steps that you take to replace the bonnet gasket. Any questions so far?
Mr. Kado, when you remove and clean in the gasket, well, we know you're supposed to grind that area and anything, but when you cleaning that, what is used to clean it, like a wire brush?
Okay. Now that is step number 8, right? Yeah. You remove the gasket and you clean the surface area. Now, what happens with the surface area, right? If the surface area is probably pitted, right, meaning that it have small sinks, you'll probably have to do a pick up or a build up, right? So in that case, you have to cry to the machine shop. So after the welder make his build up, depending on the shape or the configuration of that seat, right? It's either you could grind it or they'll have to put it on a lathe or bring a special machine and machine back that surface area, flatten it, right? So that is what I'm talking about. You're cleaning the area. So you more or less cleaning it. Most of the time we use the CRC spray, right? And we spray it on the surface and we take a wire brush and we pass it and we wipe it with a cloth, right? And make sure that surface area nice and clean, right? That is as much as you could do. But beyond that, anything too drastic, too pitted. And mainly that used to happen in petrotrin. Some of those big valves that hard to replace, right? And the time it would take when you order a new valve, right? By the time you're waiting on that valve, you still need the system to be functional. So most of the time, what you'll do, you'll do a build up on the face, on that seating face, and you'll send it to the machine shop, and they'll machine it back to specs. So when you rest the gasket and you rest you rest your bonnet on top of the body of the valve, everything will mesh up nice and it wouldn't leak. By that time, the amount of service you're getting with that, you could afford to get a new valve and install it during a shutdown. Right? Any other questions? So we pass it on. Andrea, is that good? Answer your question?
Yeah, answer my question, Mr. Kado. Thanks.
All right. So we're looking at our repacking procedure. So beside the bonnet gasket replacement, right, and the making of the flange to make making of the gasket to make your connection to the flange and so on. One of the service that you should be able to provide is the replacement of the valve packing, right? And this is just some basic steps or some guidelines in the replacement of the valve packing, right? So we're looking at the procedure now to replace the valve packing. And it starts off as all general procedure. First thing you do, you isolate. Next thing you do, you perform your standard lockout tagout procedure. Step number 3, you isolate the valve and remove it if necessary. So you isolate the system, right? You lockout tagout the system. But then you have to make sure that valve isolated. The rest of the line towards the valve isolated. So probably you'll have a bleed front or back. You bleed that, and so you make sure beside anything coming on, any other foreign matter coming through the system, that valve is isolated, right? So step number 4, you secure the valve to be worked on using a vise, right? Step number 5, you open the valve completely. You want the valve to raise off you want the disc to raise off of the seat, right? So you open the valve handle. Step number 6, you remove the hand wheel nut from the stem. Step number 7, you remove the hand wheel. Now, certain valves you're working on, you ain't bound to remove all like the hand wheel and stuff like that, right? You could just unbolt the flange, the gland flange or the gland follower, slide it up, tie it up on the handle, slide up the gland and remove your packing. But certain times you have to do these steps by removing the hand wheel and removing to get to the packing, right? It's a form it will be more convenient, it will be more comfortable for you to work on. But if by chance that they really don't want a valve come out of the system, once the system isolated, you could change your packing right there. Right? So next step number 8, you remove the packing nut or packing gland bolt. Number 9, you slide your gland flange and gland or gland nut and gland up on the stem and remove. Now if you look, the gland flange is for the bolted connection. The gland nut is if you have the union type or the threaded type, it will have a gland nut. So you slide that up. Number 10, you remove the old packing material from the stuffing box using the packing removal tool. And when we look at tool, we look at the packing removal tool. We have the stip and we have the flexible packing removal tool. So you will use which one is best suited in that application. Mainly the flexible one is to get in, like if you have a funny bend to make it flexible, right? But if you're removing the handle and all these things, the stiff one could work depending on the size of the valve tube, right? Number 11, you clean the stuffing box and the valve stem, right? 12, you examine valve stem for wear or scoring and you replace if necessary. So after you clean the valve stem, you look at your valve stem and you make an evaluation. You look for any deep marks, any deep scrape, right? And if too deep, you replace. If the valve stem seems to be worn down, you replace it also. Number 13, you use the correct cross section of packing or die forming ring, right? So when you take out the old packing, the packing will have a certain size, a certain width. That is the cross section they are talking about. Step number 14, when using the coil spring packing, always cut the packing into separate rings. Number 15, say the best way to cut the packing ring is to cut them on a mandrel of the same diameter. Remember we mentioned the mandrel, right? Same diameter, meaning the same diameter of the valve stem, right? So for instance, if the valve stem is 3/4 inch, you want to be cutting the ring on something equivalent, something 3/4 inch, a 3/4 inch pipe, a 3/4 inch mandrel. That is to make sure that when these rings cut and you form them back in the stuffing box, that they don't have no space, right? So they cover the proper circumference of that shaft, right? 16, reinstall the packing material one ring at a time into the stuffing box using the gland to push them down. So every time you're placing a ring, you take the gland and you slide it and you make sure you push down that ring as deep as possible. Number 17, slide the packing gland over the stem onto the body of the valve. 18, you slide the gland flange or gland nut over the stem and finger tightly. So you slide it. After you slide the gland, you slide the gland flange or the gland nut. That is what will compress the gland, what will push the gland down to compress the packet. Right? You slide them and your finger tighten them. Right? You ain't pulling them with the spanner yet. Just make sure your finger tighten them, the hold firm before you apply your wrench to pull it. Number 19, you replace the wheel and nut onto the valve stem. And that is the steps for the repacking procedure to replace the packing. Any questions? None? You all with me? Hello?
Yes,
right.
so far.
Yes.
Right. Now I just want to make sure because as I say, my internet has dropped sometime now.
Yes, sir, yeah.
All right, so we're moving on. Lapping and finishing operation. Now the thing with the lapping operation, this is done on the valve seat, it's done on the valve disc, right? Now you could probably use a light lapping compound on the stem of the valve to smoothen it. But our procedure is more applied to the seat and the disc or the wedge, right? So lapping and finishing operation. Only valve grade max silicone carbide extra coarse lapping compound should be used. Before starting lapping operation on the surface of the seat or wedge, secure the surface, ensure that the surface is properly machined and burns are removed. What that mean? That means the burns we're talking about in case you do any well build up, right? You pass the grinder. You know, sometimes when you pass the grinder, you see on the iron a kind of bluish, darkish color. That is the burn. That means you actually press there too hard, right? You concentrate there too much. That is the burn we're talking about, right? Now, when you're grinding anything, you're grinding a pipe, and you see that little bluish, darkish, black color, right? You're supposed to just gliding the grinder above it, like you're shining it. You're not pressing the grinder. Most of the time you get these burn, man, is when you press the grinder edge too much into the material, right? That is a kind of indication that the surface started, you use too much force there, so you might have a little unevenness. So what I'm trying to say, before you even start a lap, you try to make it as even as possible, right? So you remove all them little burns, remove all these marks. So we're looking at the procedure now. Step number 1. You put the lapping compound onto the surface of the lapping area. So the area you're about to lap, if it's the disc, you rub the lapping compound on it, right? You rub a light, even application of the lapping compound. Number 2, you apply it to the flat metallic plate or the lapping plate, right? So what you're going to do, you have a lapping plate, you're going to rub the disc against, you're going to rub the disc on, right? So you apply some of the compound onto the lapping plate also. Step number 3, for proper finish, move hand in a figure 8 motion and apply even force to all contact area till the surface is smoothly lapped, right? So you want to move the disc in a figure 8 motion, right? And you're applying even force throughout the surface area of the disc. You're not using your hand and press down one side too much. You apply it even force, right? And the thing about when they say till the surface is smooth, after you wipe it off, you look at your surface, right? Your surface look nice and smooth and thing, but still they say clean the surface and observe the proper matching between the contact area. What else do now? You have something like a blue powder, right? You place it onto the disc and you rest it back onto the seat where if you're lapping the seat and you give it a slight turn. Now when you remove it, you go see the areas where it contacts. If you realize it have a nice even blue line around, that means hey, your lapping was properly done. If you realize that some part blue, some part in have it, that means it's high and low. The areas where you have the blue, that is the high area, that's the area what will be touching. So you go back and you do the lapping process again, right? Step number 5, you reassemble the components. So once this lapping procedure is finished or completed, right, you want to reassemble your component. Now, the next, well, any questions before we move on to the practical video? Any questions so far?
No, sir.
All right.
So just one question.
Yeah.
The last thing packing of the valve.
Yeah.
I think was step 50. Right?
No,
that was with the the manual.
Yeah.
Manual come like a template for the stem.
Yeah. The manual come like a template. Right? Now, if you don't have a manual, as I say, you could use a pipe, but same diameter as the shaft. Right? So that when you put
that one no good access.
Yeah. So once you place the ring around it, it will make the complete circumference. Right? You don't want to use it too big. Or you don't want to use it too small, because when you put the ring in the stuffing box, it wouldn't fit around the stem. It will have a crease where liquid could seep through. Remember, the packing is ready to stop the leak. So you don't want that. You don't want to use too much a big shaft, so then the manual will have a space. You don't want to use too much a small shaft, because the ring now would not fit into the stuffing box. So you want to use,
All right, cool.
you want to cut the material on a shaft same diameter as the stem, right? The reason why you don't really want to practice cutting it on the stem. When you're cutting it with the knife, the utility knife, sometimes if you rest it on the stem and you press too hard, you leave a little mark on the stem now, a little groove, right? Remember, you want the valve stem, you want the valve stem complete presentation while the video player I'll call Kiza. Everybody hearing properly? Everybody hear any video?
Yeah, I hear it. Yeah, that's yourself.
Yeah, I hear.
All right. Well, I will now continue.
Yeah.
Fluids, gases, and airflow are contained in various systems located throughout a power plant. And the rate of flow in each system is regulated by valves that have to be kept in good working order. Now, there are many types of valves that you'll be servicing, but we're going to concentrate on three kinds: the globe valve, the gate valve, and the diaphragm valve. Now, the globe valve and the gate valve are two valves that are common to industrial plant use. This is a diaphragm valve. It's not as common as the globe valve and gate valve, but its use is becoming more widespread. Later, we'll remove a diaphragm valve from a system and make repairs and return it to its place. And you'll also get a few tips on some practical safety precautions for protecting yourself and others when working on a valve. Well, if you've been working in a plant for a while, you're probably aware that just about everyone works on valves at one time or another. In fact, valve maintenance accounts for at least 30% of the entire plant maintenance workload, and it can go as high as 80%. So it's likely that there will be times when a major portion of your time is spent working on valves. Now, since valve maintenance is something you'll be doing a lot of, it makes sense for you to know the right way to do it from the very start. After all, proper maintenance the first time around saves time, and it's the best way of ensuring that a valve will operate correctly and last a long time. Now, the first rule of valve maintenance is regular, close inspection. Even when a valve appears to be operating properly, it should be inspected frequently and with care. Think for a moment about an ordinary sink faucet. The flow of water through it is regulated by a single valve. As the seat on the disc wears out, most of us tend to use more force when turning off the water. Only when the faucet starts to drip do we take the time to change the washer. Well, this kind of treatment can cause considerable damage to a valve. For example, take a valve that begins to leak by the disc. Like the sink faucet, you could try to stop the leak simply by using more force when closing the valve. However, that's not a good thing to do because you'd be forcing the disc and seat together, creating excessive pressure on the yoke bushing and the bonnet threads, if the valve is like this one. Forcing a valve closed like this will also cause galling of the valve seats. If the valve is made of brass or other soft material, forcing it closed will damage not only the seat and the disc, but it can cause the stem to be bent or the bonnet threads to be stripped. So, if a valve is repaired promptly at the first sign of trouble, only minor adjustments will be necessary. But the longer the problem is neglected, the worse it'll become. During routine inspection, valves that need it should be cleaned and lubricated. When cleaning a valve, remove all dust, dirt, and chemical buildup that could interfere with the proper operation of the valve, especially on the stem and around the packing gland nuts. Be sure to lubricate these parts after cleaning them. This will keep the valve in good working order. The stem will rotate freely when needed, and the packing gland nuts won't stick when adjustments are made. One of the most common problems you'll encounter during routine inspection of a valve is leakage through the packing. Well, let's see how you would handle the problem of packing leakage. Well, the packing inside the stuffing box would be adjusted. This is done by tightening the gland nuts in a clockwise direction. This will compress the packing and hopefully stop the leakage. As the gland nuts are adjusted, take care to tighten each one the same amount. Do this by turning them alternately one flat or revolution at a time. You can also use a torque wrench, which has an indicator to show you the pressure applied to the gland nuts, or count the number of threads from the top of the stud to the nut. Make sure that there are the same number of threads on both sides. Tightening the gland nuts this way will give even compression of the packing, which means smoother operation of the valve. If the leakage doesn't stop after the packing has been adjusted, the valve will have to be repacked by removing and replacing the old packing. Many manufacturers advertise that their valves can be repacked while still in service. The valves they're talking about are special globe valves that are made with a back seat. That is, with a seating area on the stem above the top of the disc. When the valve is fully open, the back seat is seated against the top of the bonnet. Now, they do this because the back seat should keep system pressure off the packing, which means that the valve could be repacked while it remains in service. Although repacking a valve this way is convenient, it's not smart because it exposes plant personnel to serious hazards. This is particularly true of high pressure and high temperature service valves. Your plant manual will tell you about precautions to take when working on high pressure and high temperature service valves. Frequent inspection of valves will let you plan your maintenance or repair work when you first notice a worn part or a problem. If problems are not detected early, or if worn parts are not replaced before they break down, it could result in an unscheduled plant shutdown caused by an inoperative valve. Also, keep an eye out for other personnel who might be operating a valve improperly. Damage through improper operation can be a real headache. Show them the right way, but do this in a helpful manner, and they will be glad to know. No one wants to cause unnecessary damage to plant equipment. Well, valve inspection should be a part of your routine, and be sure to clean and lubricate valves when you see that they need it. There are certain things you should always look for when inspecting a valve. You may find that the packing gland nuts need adjusting. Suppose that while adjusting the nuts, you find that they won't turn anymore. Well, this could mean that the packing gland is bottomed. Bottoming happens when the packing gland is adjusted all the way down against the bonnet and can't be adjusted further. Now, when you can't turn the gland nuts anymore, the valve must be repacked. But before you can begin to repack the valve, you'll have to make certain preparations regarding system and plant conditions. The system will have to be tagged out for a work release by the operations personnel. A work release is a form stating that the system has been put in safe condition for repairs. You must not start without it. A work release has to be issued whether you plan to repair the valve in place or take it to the shop for maintenance. While operations personnel are getting your work release, there are a few preliminary jobs you can do. Look at the nameplate on the valve you're going to repair. Copy down the manufacturer, the type and size of the valve, the serial number, and the model number. With this information, you'll be able to get correct technical information and any parts for the valve that you might need. If you're going to work on the valve in place, you can check to see if you need scaffolding, rigging, extra lighting, or other special equipment to do the job. After you've written down the information from the nameplate and gathered the special equipment and your tools, you'll be ready to start when the work release is issued. Now, there may be some thermal insulation to remove before you can work on the valve. Unless you know otherwise, it's best to assume that it's made of asbestos. Be sure to take the proper safety precautions. Wear the required safety equipment while removing the thermal insulation. You can probably remove any insulation while waiting for the work release. Once you've got your work release, but before you begin, make sure that all pressure in the system is bled off the valve and that all fluid is drained. If there is a vent or drain valve nearby, leave it open while performing maintenance. In addition, there may also be quality assurance requirements that you'll need to check. They concern cleanliness, control of parts, and inspection procedures during maintenance. The type of maintenance to be done will determine where the valve is repaired. It saves time if the work can be done with the valve in place rather than in the shop. But wherever it's done, be sure that the work area is clean, well lit, and adequately ventilated. And see that you have all the tools you'll need. A frequent job you'll have is repacking a valve. This usually can be done while the valve is in place, but not in service. After a short break, we'll see how a gate valve is repacked, whether in or out of the system. Once the work release has been issued and the work area prepared, valve maintenance can begin. Now, most valves can be repacked while in the system, but for our demonstration, we're going to repack this gate valve here in the shop. Repacking will be one of the most common valve repairs you'll perform. If the valve were to remain in place during repacking, we'd check to make sure that there was no pressure remaining in the system by opening a drain or vent valve. We'll begin by removing the hand wheel, which will give us access to the packing gland and stuffing box. First, loosen the hand wheel bolt by turning it in a counterclockwise direction. When it's loose enough, take off the nut. Often the hand wheel will stick, but a light tap should loosen it. Next, we'll clean off any buildup of dirt on the threads of the gland bolts with a wire brush. Lubricant is sprayed on the studs to make the gland nuts easier to remove. Again, loosen each gland nut in a counterclockwise direction. When they're loose, take them off along with each of the washers. Be sure to put these, and of course all of the parts you remove from the valve, in a safe place where they won't be lost. The bolts and nuts are made of materials that are compatible with system fluids or may be specially heat treated. Replacing them with parts of the wrong material can cause corrosion or part failure and unnecessary repairs. With the gland nuts off, the gland itself can be raised and removed to allow access to the packing. If the gland can't be removed, a piece of wire or string can be used to hold it up and out of the way. We now have access to the packing. We'll get the packing out of the gland with a packing removal tool, keeping the sharp pointed end of the tool clear of the stem so it won't be scratched or nicked. Carefully remove the first ring of packing. This valve has 3 rings of packing, and they are taken out one at a time, always keeping clear of the stem. If the stem were scratched or nicked, it would cause leakage when the valve is back in service. When all the packing is removed, check to see that no remnants remain. Now the studs, nuts, and the stem can be cleaned. First, the threads are cleaned with a wire brush to remove dirt or other materials such as chemical buildup. Generally, a die and tap are used to make new threads, but when they're used for chasing, the die is threaded on the stud, like this, and the tap is threaded into the nut, as you'll see in a minute. Make sure the die is properly lined up so the threads are not damaged. Then the wrench is used to thread the die down the studs. If the wrench becomes hard to turn, back off the die a few turns to clear the threads. The die is removed when chasing is completed, and the other stud is chased in the same way. This process will make reassembly and later adjustments easier. Now, there are still other parts of the valve that must be cleaned. The stem is cleaned with a fine emery or crocus cloth. This removes dirt and chemical buildup along with any burrs. The stem can also be checked for sitting and any other visible damage. To chase the packing gland nut, it is first put in a vise to hold it securely in place. Then the tap is threaded into it, rotated back and forth, and taken out. The nut is removed from the vise, and the process is repeated for the other stud nut. Finally, while you're wearing a pair of goggles, low-pressure air is blown into the stuffing box until it is clear. This will remove any debris that might have fallen into the stuffing box during cleaning, and the goggles will protect you from debris should any fly out as you're applying the air. Well, we're now ready to install new packing. Packing usually comes in two ways, either in bulk form on a spool or roll that can be cut and fit to the size needed, or in various pre-cut sizes. Now, with pre-cut packing, the correct size and number of rings are provided and can be fit around the stem and into the stuffing box. Both types are preformed, that is, made to be the same shape as the stuffing box, whether it is round or square. Obviously, pre-cut packing saves time, but it is more expensive than bulk packing. Once in a while, pre-cut packing is broken or cracked and can't be used, so be sure to look it over before using it. If the rings are arranged in a particular order, be sure to keep them in that order. Some valves may require more than one type or shape of packing. When there are more than one type, the rings are packed in a specific order. By keeping them in that order, you'll put them into the valve in the proper order. Now, the kind we're going to use is in bulk form on a spool. It's preformed to the shape of the stuffing box. Unwind some of the packing and wrap it around the valve stem one turn to form a ring. Then, using a packing knife, make a cut mark where the line of packing meets the end. Cut the measured packing on a block of wood, making a straight cut that is perpendicular to the stem. This is called a butt cut. The ends of the packing will butt against each other. By making a mark with a knife on the wood, we can measure and cut the next two rings of packing to the exact size of the first ring. Now, besides the butt cut, the packing can be cut at a 45-degree angle, and this is called a miter cut. Although there are other specialized cuts, the butt cut and miter cut are the most common. If there's any doubt, check the manufacturer's manual to see which type of cut the valve requires. Now we're ready to pack the valve. Shape the first piece of packing into a ring by forming a circle, and then rotate it another half turn. And then fit it carefully around the stem, making sure the ends meet. Press the packing into the stuffing box until it is inside all the way around. And then slip the packing gland over the stem to compress the packing. The remaining rings of packing are done in the same way, again making sure that the ends meet. This is important because if the ends of each ring do not meet, there could be leakage through the packing when the valve is in service. In addition, the place where the two ends of each ring join should be staggered to keep them from lining up, because if they did line up, a path for leakage through the packing could result. If only two rings of packing are required, each would be separated by 180 degrees to keep the ends of one ring apart from the other. 3 rings would be separated by 120 degrees. 4 or more rings would be separated by 90 degrees. When all of the packing rings are installed, the packing gland is put over the stem and pressed into place, seating the final ring of packing. Then each of the studs are lubricated to prevent the nuts from seizing during service. and to allow for later packing adjustments. The washers and nuts are put on and screwed down by hand. To tighten the gland nuts evenly, they are alternately turned one flat at a time, making the same rotation on each with a wrench. At this time, be sure the valve is not overpacked. No packing should be showing, and the gland should fit approximately 1/8 of an inch into the stuffing box. See that there is proper thread engagement. Usually, one full thread of the gland stud should extend above the top of the gland nut. The studs are normally made to ensure proper thread engagement. After the nuts are evenly tightened, lubricant is brushed on the threads of the stem. The hand wheel is put back into place and the retaining nut is put on and tightened. That completes our task of repacking the valve. As you can see, we were able to do it without taking apart the entire valve. Now, there are a few more things you should remember about packing installation. Some types of packing may require special treatment. They may have to be soaked in oil or water or other lubricant before they're installed. This allows the packing to swell to its proper size. The lubricant also permits the stem to rotate easier with less wear on the packing, and that will extend the life of the packing. If the packing supplied to you needs this treatment, it should be indicated on the package. When in doubt about whether or not to soak packing, check with your supervisor. Well, we didn't have any problems packing this valve, but you may have to pack a valve that has a packing gland not long enough to seat the packing in the gland. A tool called a split ring packing compressor can be used. The compressor is usually made of wood or soft metal and is slightly smaller than the packing gland, so it'll fit into the stuffing box. Once the valve is packed and reassembled, it should be cycled several times. This helps to seat the packing. After cycling, the gland nuts are rechecked for even tightness. This valve is now ready for storage or service. If the valve is put back into service, there's one final step. The packing must be broken in. And this is done in the following manner. As the system and valve are brought to their normal operating temperature and pressure, there may be some initial packing leakage. Well, the valve should be allowed to leak slightly for about 10 or 15 minutes. Then the packing is adjusted by taking each gland nut down one flat at a time until the leaking is almost stopped. The valve is allowed to set for another 10 to 15 minutes before adjusting it again to ensure that all leakage has stopped. Usually 10 to 15 minutes will give the packing time enough to settle as it is adjusted. By alternately taking each gland nut down one flat at a time, there will be even pressure on the packing. This process of breaking in the repacked valve should ensure that the new packing will not leak. It will also extend the life of the packing because the packing is compressed only enough to stop the leakage, leaving further compression for later adjustment requirements. Well, now we've seen how a valve can be repacked without taking it apart completely. After a short break, we'll watch as a valve is removed from the system so that maintenance can be performed on the flanges and gaskets to repair a leak. We've seen how a globe valve is repacked without disassembling it completely. Now let's take a look at some of the other aspects of valve maintenance that you'll need to know about. We'll see how a globe valve is taken apart, inspected, and how certain parts are repaired. And we'll watch as it is reassembled once our maintenance work is finished. Well, we've cut away half of the body on this valve so that you can see the internal parts as we work on them. And the valve is braced in this vise to keep it from moving as we work. The first step is to loosen the nut on the hand wheel. Then the gland nuts on both sides and the bonnet nuts are loosened. Unscrew the gland nuts and remove them to relieve pressure on the packing. Now, unscrew the bonnet nuts and take them out. This will allow us to lift off the hand wheel and bonnet assembly. Remove the flexitalic gasket. The hand wheel is rotated in the closed direction as far as possible. Then the nut and the hand wheel are removed. Now we can rotate the stem out of the bonnet. If you're unable to turn the stem by hand, you can use a wrench to do it. Take care not to damage the stem with the wrench. A soft-faced wrench or a piece of soft material between the wrench and stem will help. Apply the wrench between the disc and back seat. If you should accidentally mar or nick the stem, it won't cause leakage when reinstalled, since it does not come in contact with the packing. But if you were to apply the wrench above the back seat or on a threaded portion of the stem and scratch it there, damage would result. The packing gland will come off as you rotate the stem. When the stem is out, the packing can be removed. Usually, the packing is taken out with a packing removal tool. With the stem out of the valve, the packing should come out easily. On this small valve, we can just turn it over and push the packing out. Now that the packing is removed, the bonnet and stuffing box can be cleaned and inspected. Check here for steam cuts or pits on the seating surface of the bonnet or body. If any are found, they must be repaired before the valve is reassembled. Minor damage can be handled by lapping the seating surfaces. Deeper cuts or pits may have to be machined on a lathe before they can be lapped. The lapping is performed in the following manner. To begin, put a small amount of lapping compound on the block. Usually you would start with a coarse grade. Rotate the bonnet in a figure 8 motion, being careful not to exert excessive pressure on the bonnet. A light downward pressure is best. In lapping, the weight of the part may provide enough pressure to smooth the surface. Now wipe off the lapping compound and inspect the seating surface. Repeat this process as many times as necessary to remove the damage. While lapping, vary the compound grit. Use finer grades to give a smooth finish. When resurfacing, be careful not to remove too much metal. You must not exceed the specifications that are in the manufacturer's manual. This caution is especially necessary when a power grinder or lathe is used. Now, if too much metal is removed from the bonnet or body seating surface, the flexitalic gasket won't fit properly, and leaking will result when the valve is put back into service. Deep cuts or pits that cannot be removed by lapping may be filled by welding before they're machined on a lathe, but it may not be worth the time and effort to try to repair the valve. It would be better to replace the valve. If you find a valve badly damaged, check with your supervisor to determine a course of action. The stem and disc are inspected next. As you look at the disc, you should be able to see a clearly defined area where it has been seating. This valve doesn't have a clearly defined seating area. If you can't locate this, it's quite likely that the disc hasn't been seating properly, if at all, and that the valve has been leaking. This visual method is a rough check. For an accurate check, spotting in is used. Now, the first step in spotting in is to be sure that the disc is not free to rotate. During spotting in, it must not be allowed to rotate. To keep it from rotating, use a piece of shim stock. Another method is to put the shim stock between the disc and stem. To spot in a valve seat, apply a thin coating of Prussian blue evenly over the surface of the disc, using bluing that won't dry. After bluing the disc, put it into the valve and on the seat. Rotate it 1/4 of a full turn using a light downward pressure. Then take it out and look closely at the valve seat. A flashlight may be necessary to provide sufficient light. If proper contact was made, you'll see a thin blue line like this one. When you've finished inspecting the valve seat, wipe the disc and seat to remove the bluing. Then put a thin, even coat of bluing on the seat. Put the disc back into the valve, give it a 1/4 of a turn, again with a light downward pressure, and take out the disc. Now you can check the disc for proper seating. It should have a thin, unbroken line around it. If it doesn't, the disc and seat are not fitting properly. If there are imperfections to the disc or seat, you'll have to repair them. However, before repairing a disc or seat, check to see if these parts are designed for replacements. As in this example, the seat and disc are replaceable. If they are, it may be more economical to replace them than to spend the time making repairs. Let's say that you have decided to repair the damage. If you found minor imperfections on the disc and seat, you would use a method called grinding in to repair them. It's done by applying a small amount of lapping compound evenly to the disc and putting it into the valve and on the seat. The lapping compound should be changed frequently by removing all of the old compound from the disc and the seat. Then apply another thin coat. Rotate the disc back and forth over the seat using a light downward pressure. Move the disc forward 1/4 turn occasionally to ensure even grinding in. Always be sure that the disc is tightly attached to the stem so that they both rotate together. If you can't keep them from moving separately, you'll have to use a lapping tool in place of the original disc and stem. However, this is referred to as lapping. Another type of disc is a gate valve disc with a flat seating surface. To repair a disc with a flat surface, like this one, a lapping block can be used to remove minor imperfections. Lapping compound is applied to the disc, which is then put on the block and rotated in a figure-8 motion using the same light downward pressure as before. You should inspect the disc often. Remove all of the lapping compound and then make several strokes on the block. Inspect the disc closely. Dark spots indicate areas where the disc is not seating squarely. Now let's go over the lapping and grinding in processes again briefly. When the disc is rotated against the valve seat, it is called grinding in. And when the disc is rotated against another surface, the block, it is called lapping. Both processes use lapping compound. Lathes and reseating machines can be used to resurface a valve seat or disc. A lathe is generally preferable to a reseating machine, especially when repairing very hard metals such as stellite. This is because it takes less time to use a lathe and the cutting can be controlled better. Another part of the valve that should be inspected is the stem bushing. The threads of the stem rotate on the threads of the bushing to open and close the valve. For this reason, the stem bushing receives a lot of wear as the valve is operated. And when the bushing threads wear out on a rising stem valve, you can't close it anymore. System pressure will force it open. Well, check the bushing threads carefully. If they're worn, it's best to replace the bushing. Usually, the bushing will be tack welded in place, and you'll have to use a hacksaw or file to remove the tack weld. The bushing can then be turned out with a wrench. The bushing threads are different from the stem threads, but when the valve is disassembled, this won't cause any problems in replacing the bushing. However, if the valve were in place with the bonnet attached, the stem would have to be rotated at the same time the bushing is being removed and threaded into the bonnet. If it's not done this way, the stem and bushing threads will bind and prevent you from installing the bushing. Well, the valve stem should also be checked at this time. It must be straight. A bent stem can cause excessive and rapid wear to the valve. Just a slight bend in the stem could render the valve inoperable, and it may also prevent the packing from sealing. To check the stem, place it on a lathe or V-block, as we have here. The total runout is checked with a dial indicator. The dial indicator is set up to touch the stem, and as the stem is rotated, the runout is indicated on the dial. If the dial remains constant on 0, the stem is straight. As you can see, this stem varies by about 10 thousandths. Well, you can also get a fair idea of whether the stem is straight by rolling it across the workbench. If it rolls smoothly without a bumpy motion, the stem is straight. As you look at the stem, there should be no space between the bench and stem. With the valve fully disassembled, all threaded surfaces should be cleaned thoroughly. A wire brush can be used for the large stem threads. The bolt and stud threads should be chased with a thread chaser. As we discussed earlier, this will make them easier to reassemble. Finally, inspect the flanges. The flanges of both the valve and pipe should be cleaned with a wire brush before inspection. You may need a putty knife to scrape hard-to-remove material. Be careful, however, not to nick or gouge the surfaces with the scraper, or it could cause leakage. Now, if there had been flange leakage while the valve was in service, repairs would be made in a similar way to those used to repair body-to-bonnet leakage. While the valve is out of the system and disassembled, you may want to sandblast the parts and then paint the exterior surfaces. This will help preserve the valve. With the cleaning and inspection complete, we are ready to reassemble this valve. An important step in putting a valve back together after repairs are completed is lubrication. All moving and threaded parts should be well lubricated during assembly. Many lubricants, both wet and dry, are available, so be sure to use the appropriate type for each surface. Keep in mind what the valve will be used for. Well, once these parts are lubricated, put the stem through the bonnet and slide the two-part packing gland over the stem. Then carefully thread the stem through the yoke bushing. Continue turning until the valve is near the full open position. Now we can put this assembly back on the valve body. First, set in the flexitalic gasket. Always use a new flexitalic gasket. Never reuse one which has been previously compressed. It will not seal properly. Put the valve on the seat. Replace the body to bonnet bolts and tighten them evenly to compress the gasket uniformly. Using a cross torque pattern, the manufacturer's manual will give you the proper torque value. Be sure to check the disc in the fully open position. This prevents the disc from being driven into the seat. When torquing the bonnet bolts, ensure the bonnet seats squarely on the body of the valve. Once the bonnet is installed, the valve can be packed. This is done the same way as when the valve is connected to the system. Finally, if the stem bushing has a grease fitting, be sure to grease the valve stem after completing the assembly. Well, that's it. The valve is now reassembled and ready to be put back into service. Well, we've been through a valve overhaul. We mentioned that it may be necessary to replace a valve if severely damaged. Several things should be considered when choosing a replacement valve. For example, the new valve must be the same type as the old valve, and it should be rated for the same kind of service. Well, let's say that the damaged valve was rated for 150 pounds WOG. The replacement valve must be rated for at least the same service. However, it could have a higher service rating. The flanges on the new valve must also be the same size and type as those on the old valve, so that they'll fit the pipe the valve will be attached to. We looked at the techniques used to overhaul a globe valve. Now, I'd like to take a moment to talk about some of the differences you'll encounter in performing maintenance on gate valves. One of the main differences is the double seating surface that a gate valve has on the disc and seat. The disc can be removed and lapped on a block using the same procedures as we did when we lapped the bonnet of the globe valve. Now, the seat on a gate valve is harder to repair than the seat on a globe valve. It must be removed before it can be lapped or replaced. If the seat on a gate valve is non-replaceable and too damaged to be repaired, the entire valve must be replaced. Finally, unlike on the globe valve, the seat and disc of a gate valve cannot be ground or spotted in. Well, these are the main differences in maintenance that you will find between the gate valve and the globe valve. Well, we've covered a lot of ground in this segment. We've talked about the way a valve is disassembled, inspected, and repaired. We've seen how it is put back together when maintenance is completed. We'll take a short break now so you can review your text and discuss some of the specifics of valve maintenance in your plant with your instructor. During a routine inspection of this system's components, a mechanic found this diaphragm valve to have a flange leak. He has decided it will have to be taken out of place so the flanges and gaskets can be inspected and repaired. If the mechanic suspected that there were other problems with the valve or that it was time for regular maintenance, it would be taken to the shop and disassembled to check for diaphragm damage, corrosion to the internal parts, and any other damage that might prevent it from operating properly. Now, the way this valve will be removed is similar to the way most other types of valves are taken out of a system. Let's see how it is done. The work release has been received. The system has been tagged out, and we're ready to begin. The first step is to spray all of the flange bolts with a penetrating lubricant. This will make them easier to loosen. Next, each bolt is loosened but not removed, allowing the valve to be separated from the pipe while still supported. This line of pipe was drained before our work release was issued. However, a small residual amount remains. The water you see dripping from the flange connection on the right is just some water that didn't drain completely. When the bolts are loose in their sockets, they can be removed. Take out all but one of them on both sides, making sure the ones that are left are on opposite sides and diagonal from each other. Before taking out the last two bolts, the valve must be supported so that it won't fall. If it did fall, it might injure personnel or damage the valve. Damage to seating surfaces of the valve and pipe could result too. Without support, the pipe could be bent or sprung. This could result in leakage when the valve is reinstalled. And if the connections were sprung, there could be difficulty in aligning the pipe and valve flanges when it's put back. With a small valve like this one, you can just get someone else to hold the valve in place while you take out the last two bolts. When taking out a large valve, you'll need rigging to give the proper support to the valve as it's disconnected. Well, lift the valve out carefully so that no damage occurs to the flanges. Check the flanges for nicks and corrosion. The surfaces should be smooth. Take off the gaskets on each side and put them with the bolts. Be sure to keep these parts in a safe place. Well, since the only repair needed on this valve is a flange gasket replacement, we won't take it to the shop. The mechanic will cut new gaskets to replace the damaged ones. While he's doing that, we'll talk about the disassembly and inspection of another diaphragm valve. Diaphragm valves are becoming a popular type of valve for industrial use. They provide a highly effective control for a flow containing acids or caustics. The construction of a diaphragm valve is somewhat different from that of a globe or gate valve. Now here, we have a diaphragm valve with a cutaway body so that we can see the internal parts. This valve is similar to the diaphragm valve the mechanic removed earlier to repair a flange leak. The diaphragm forms a leak-proof barrier that prevents system flow from coming in contact with the valve stem and other internal parts. With a diaphragm, packing is not needed. The diaphragm can be made of just about any flexible material that is resistant to fluids, chemicals, and gases. However, like all other valve parts, the diaphragm will eventually deteriorate, so it must be inspected occasionally. The preliminary steps for repairing a diaphragm valve are the same as for any other valve. Identify the problem. Find out all you can about the valve and the system it's connected to. Get a work release and gather tools and any other material you might need. Although a diaphragm valve can be disassembled and repaired in place while it's not in service, we will work on this one in the shop, and as always, following the manufacturer's recommended procedures. Before starting to disassemble the valve, apply a penetrating lubricant on the body-to-bonnet bolts to make them easier to loosen. The first step is to remove the bonnet. This is done by taking off the nuts on the body-to-bonnet bolts. Be sure to put them in a safe place where they won't get lost. Once the nuts are off, the bonnet, along with the stem and diaphragm assembly, are lifted off the valve body. Now, inspect the internal body of the valve. If there is excessive corrosion, the valve should be replaced. Well, this one's in good condition. The diaphragm is removed by unscrewing it from the compressor. Make several rotations of the hand wheel to disengage the compressor from the bonnet. Now, the diaphragm, backing plate, and the stem can be rotated until they're free of the bonnet. Next, loosen the finger plate and take it off. The inside of the bonnet can be checked for signs of corrosion and wear. Unscrew the stem from the diaphragm and separate the diaphragm and backing plate. Examine the diaphragm closely. Flex it like this to see if there are any cracks or holes. If the diaphragm shows signs of deterioration, it should be replaced. The same is true of the backing plate. Inspect the stem and clean the threads with a wire brush to remove dirt and corrosion. Corroded stem should be replaced. This one is in good condition. Now that all of the parts have been inspected, the valve can be reassembled. The first step is to put the diaphragm over the backing plate, and then attach the diaphragm to the stem and compressor assembly. When the diaphragm, compressor, and stem are threaded into the bonnet, the compressor will have to be aligned with the finger plate, as you see here. The compressor is also aligned with the tabs on the diaphragm. Put the finger plate on the bonnet and thread the stem with the diaphragm and backing plate attached through the bonnet, matching the bolt holes of the diaphragm with the bonnet bolt holes. Then rotate the hand wheel, bringing the compressor up into the bonnet. Now, place the bonnet assembly on the valve body. Insert the bonnet over the lubricated body-to-bonnet studs and tighten them. Be sure the valve is in the open position. And remember, always tighten the bolts to the torque specification of the manufacturer. The last step is to remove the cover of the grease fitting and apply the proper lubricant. This is especially important for valves that operate under corrosive conditions. This valve would be ready now for installation. We've seen how different valves are overhauled. Now let's see the general methods used to install valves into the system. Earlier, when a mechanic took out a diaphragm valve to repair a flange leak, he had to get new gaskets to replace the old ones. Often, gaskets are ready-made. However, for this valve, new gaskets will have to be cut. Let's see how it's done. We'll use a gasket cutter and layout board. The proper gasket material is selected from the supply area. It may be neoprene, Teflon, or rubber. Now, these are going to be made of rubber. The blade holder and extension arm are first set for the outside diameter of the gasket. The center pin is pushed through the rubber and inserted into the center hole. The blade is rotated back and forth until a full circle is made. Now we'll change the length of the extension arm and set it for the inside diameter of the valve opening. Then the cutting is done in the same way that it was for the outside diameter. After making one more gasket for the flange on the other side of the valve, we would be ready to install the valve and the new gaskets. The mechanic has made the gaskets for the diaphragm valve he took out earlier. Let's see how he reinstalls that valve. Before positioning the valve, clean it with a wire brush and check them for nicks or cuts. Make sure that the surfaces are smooth. The valve flanges have already been cleaned. Be sure you always clean the flanges before you install the valve. Have someone hold the valve in place. Now remember, you'd need rigging if the valve were large. Lubricate and replace the two bottom bolts on each side. Slip in the gaskets. They will be held in the proper position by the two bottom bolts. These are rubber gaskets and do not need to be lubricated. Other types, like rubber O-rings, require lubrication to provide a tight seal. Then put in the remaining bolts, lubricating each one as it's installed. Tighten the bolts on one side. Make sure that they're evenly tightened by using a cross-torquing pattern. Then do the same on the other side. The valve is securely installed now. Now collect your tools, ensure your work area is clean. When the work release is cleared and the valve is reinstalled for service, inspect it carefully for leakage and make any adjustments that might be needed. The job is now complete. Well, this concludes our unit on valve maintenance. Be sure to go over the material in your text carefully and always follow the manufacturer's and your own plant's procedures when working on valves. In this way, you'll be doing your job well and helping to keep things running smoothly. Good luck and good work.
Well, everybody with me still? Or they drop asleep?
Sleeping. Yeah.
Yeah, we did.
Right. Well, I hope the practical video was insightful. I hope it answered any questions. Remember, as I was explaining, when you cut the gasket, that you install the bottom bolts and you just slip in the gasket. You see how the bolts, how the gasket just rests on the bolts. It didn't fall through, right? So anytime you cut the gasket at all and you realize that, hey, this gasket look like it's a little too small, like it isn't matching up the full raised face of the plant, you know that's something wrong, right? Because that gasket is supposed to fit like the edge of bolt hole to the edge of the next bolt hole, the inside edge, right? Any questions?
No.
Right.
Nah.
Well, didn't get in contact with Kiza, but as I say, by Monday, please God, if you don't get any material, just give me a call, and I'll make sure that that she send it. So all you have to do is when you open it, you'll see like a little message. You click on it, you will see the link to YouTube. You copy the link, you put it in search for YouTube, and you get the same video, right? So you have a step-by-step breakdown on everything. So, well, there's no question. I hope that this little practical and the little things we talk about that you will remember, you'll go over and you'll put it into practice when you're reaching the shop. I hope it was helpful, and wish you all the best in the future. Right? So if there are no questions, any questions?
No.
All right.
We got a question when we finish up.
When you reach the shop. Right.
Correct.
So with this said, you all enjoy the rest of the weekend and stay safe. Remember social distancing. People in Wassa, remember that Monday you'll be returning to work, right?
Yeah.
If, everybody know that? Some people.
I was alone.
Right. Yeah, so well, I will make a pass around my comments and them and make sure that they know, because them in our internet, they have phone. Bye. Well, take care and enjoy the rest of the weekend, and probably see you soon.
Yeah.
And once we have any,
very soon.
yeah, once we have any practical, any online course given, I'll let you all know and we'll make the arrangement.
All right.
So you all take care and enjoy your night.